Yes.
Okay, so let's introduce you to Packtin. Packtin was born as a spin-off from the University of Modena and Reggio Emilia here in Italy, near Bologna. And we work on circular economy, developing a new technology to help the food transformation industry to be more sustainable. What we are doing is to create a circular model where we want to recover, and we are recovering food byproducts from different agri-food company and revalorizing them. To do this, we can divide our process in 4 steps. The first one is the recovery of agri-food byproducts. This is a quite innovative way to create this kind of supply chain. And the second step is the stabilization of this food byproducts biomass. And then revalorizing them through extraction and for the creation of new raw material from byproducts, and to create a new, very interesting products using this raw material we recover from the byproducts biomass. So I show you what is the first step. We recover the food byproduct and we treat it as a food. So we want a certain quality from the producer of these byproducts, but we pay for it. We recover it, we bring it to our company, we develop a new technology that can drying it in a very sustainable way in terms of energy. We can treat, we can dry the biomass using at maximum 40 degrees as a temperature and very, very few hours. For the moment, our best is 8 hours for the removing of 80% of water in 1 ton of biomass. And so we obtain a dried product that we milling with a new kind of technology we developed with our other company, and so this milling we allow temperature that's help to do not destroy the substances inside the food product biomass. In this slide, you see orange. We focus more on orange, but we strongly work even on tomato. And for example, there are 2 samples of the final product we obtain for the final product of this first step. So we obtain this kind of flour that have a very, very interesting nutritional value. In the left side, you can see the one of the orange, but it's not interested today. Let's see the right one, on the tomato one. And for 100 grams of this flour we obtain with this new kind of drying technology, we can have 9% of fats, with 2 points of unsaturated fat, 12 grams of carbohydrate, the half is sugar, a big quantity of fibers, such a quantity of protein. We think we are more or less about 14–15% on the dry products, and a big amount of carotenoids, including lycopene, of course, and that's a more or less 1.5 gram for 100 grams. We are testing this product in different sectors. The first one is the zootechnic sector. The second one is the food sector, of course. And the third one is the cosmetic and pharmaceutical sector, because it's a very, very great source of carotenoids for different applications in cosmetic and food supply and so on. So this is the first part we are doing right now, and we creating the pilot scale plants that can treat 3–4 tons by day of this tomato peel or orange peel as we want, and we are testing this flour to selling to the market with a very, very good response from the market too. But Packtin doesn't stop here. We have the next step. This one is a new prototype. We developed this in a prototype scale. For the moment, it's 20 liter. We are projecting the 1 ton extractor. Is an extractor can use several energy as ultrasound, microwave, pressure modulation, mechanical steering, hydrodynamic steering, And we can mixing this technique all together. We do it. We can do it sequentially, and with this machine, we can separate the constituent, the raw material inside the biomass. For example, I showed before. For example, with this machine, we put inside the tomato peel, we can separate easily in more or less 2 hours the sugar and the water hydrophilic vitamins in the first step. We can remove fat and oil in the second one, recover the pectin inside the tomato peel, the carotenoids, and the last extraction is about the hemicellulose and cellulose inside the product. So we can separate all the fraction of this byproduct with this new kind of technology in less time and using less energy of the state of the art for the moment. That you are using different technology to do it. This is one plot extraction machinery. Of course, the machine is suitable for 4.0 remote control. We can save the recycle of extraction. So for the moment, in the tomato peel, we load the tomato peel and we just press one button and the machine just know what have to do. So removing the vitamin sugar first and then so on. And of course, with this new raw material, we can sell it directly to the market, more or less the same market of the flowers. So zootechnic, food, and cosmetics and pharmaceutical, or create very innovative products, totally sustainable. Such an example, I reported just 2. The first one could be interesting even for the tomato industry, is a coating that can extend the shelf life of the tomato after harvesting. So it's a post-harvest technology, not on-the-field technology. It's composed by hydrocolloids recovery from orange, but even from tomato biomass. And we can include inside antimycotic, antimicrobial compound derived from other kind of extraction. The coating is an ethylene barrier, so slow down the ripening of the tomato. That is a climacteric fruit, so it's very sensitive to the quantity of ethylene it can absorb. And of course, this one is a totally edible coating. So because and another thing I want to add is totally water-based. So if the final consumer want to remove it, this time with a washing, it can remove the technology. It's a totally different approach from the wax. That's the technology are used today on apple or, for example, on orange, because of course, wax is not washable. So to remove the technology, you have to peel the fruits. But in a lot of fruits, even in the tomato, a lot of nutrient constituent is inside the peel. And the last part of pectin development is the R&D in the next year is to use the big amount of cellulose and hemicellulose we can recover from all these kind of food byproducts and food biomass, such as tomato, orange, and other, to use it as the first step to creation of compostable and biodegradable packaging in 3 ways. The first one, and we did already some tests with the other university, we use our cellulose recovered from tomato and orange peel as an optimal substrate for fermentation for the bacteria to develop polylactic acid or polydroxyalkanoate. So, for example, PHB, that says polydroxybutyrate. The second step is to use this kind of fibers as cellulose, hemicellulose, pectin, amylopectin, modify chemically to obtain a thermostable polymer that can be extruded to obtain final products. Remains, of course, biodegradable or compostable. And you see here in the picture, this one is an extendable, is a stretching film for food application we developed. It's based totally on vegetable fibers, such as cellulose from tomato and some pectin from orange peel. And the third way we can create sustainable packaging is to use this fiber, and we recover from biomass, as a filler for normal plastic and bioplastic. We did some tests with a company in Torino, here in Italy, that he is creating container for food made by PHB, so polyhydroxybutyrate, and we can reduce the amount of PHB of the 30%, substituting it with cellulose from tomato peels. It's another kind of example of how we can use this kind of new raw material we obtain from our process. We are a very young team, and apart me, there is Andrea Quartieri, this CEO and AP manager. Francesco Bigi, the younger of the team, is just 27, is our prototype developer and food engineer. Andrea Bedogni, our CFO, administration manager, and of course, Professor Andrea Pulverenti from the University of Modena and Reggio Emilia. That is a very expert food microbiologist that's helped us to develop our technology, respecting the hygiene and the microbiological quality of the final products. And of course, we have a lot of collaborators. We work strictly every day, like Vittorio Molinari, our expert business, Francesco, our lawyer, Federica, patent lawyer, and graphic and communication manager. So we are Packtin. I think it's a very innovative startup. We're growing to bring more sustainable in food process, about the using of food byproducts. That's nowadays a quite big amount all around the world. And now we are building our first setup here in Italy, in North Italy, here in Reggio Emilia. But the idea is when we have set down all the plant, this is totally working, we want to replace it all around the world to bring our sustainable all around the world. Because of course, every state, every country have their own byproducts, and it's correct that they can revalorizing it 100% on their soil and not moving ton and ton of biomass around the world to valorizing it. Because we have to remember that circular economy is not a global economy, but it's a district economy. So to be sustainable, we have to replace the technology where they are needed. So everywhere that there is a lot of production of vegetables, and of course a lot of production of food transformed by vegetables. And for example, here in Reggio Emilia, we are in the food valley, so we have a big company that can transform tomato, and then and we are recovering a little part, because 3 tons by day is a very, very small amount. It's not so big. And so we are recovering a tomato peel from a company here in the Emilia-Romagna, where we are site. Orange peel, of course, some byproducts from the wine industry. We are working on even on peas, soya, carrots. So every vegetable product can be transformed for production of juice or for other kind of transformed food. So this is a very short introduction about what the Packtin and what we are doing and want to do in the next year. So if you have some question here, thank you for your attention.